Okay, what's up, guys? Now it's on to kind of part two of the review from last year. Now, if you didn't have me for Algebra 1, you might not know this yet. This might be new, this thing today. Okay, now first we need a little inquiry into what we're doing. As you can see, it's got graphing assignment. It's really not going to go too bad. Like, it's not that long. So let's talk about the reasoning behind it. Now, in the first kind of part of this, we went over stuff that involved lines, okay? Well, now that's going to change a little bit, and here's an example. Here's an example of something that'd be a line. A go-kart charges a $50 membership and $35 to race. Now let's complete the following table for the information. Now this is why this would be a line, okay? Well, if I have 0 races, I had to pay the membership. That's 50. That's where that 0.50 comes into play at. And then after 1 race, I'd pay $85. Then of course 2, we just keep on really adding 35 to this. So it's going to be 120, 155, 190, 225, and 260. Okay, it's a line because it goes in the same direction and it goes up by a constant rate every time. Okay, rate of change is constant. Okay, now this is going to change here. A go-kart has 380 racers and charges $35 to race. For every $1 decrease in price, 20 more racers will come, because if you decrease the price, more people come is the idea. Now complete the table. So if you charge $35 cost of a race, and you're charging that for every race for 380 racers, so 35 times 380. Then these guys would make $13,300. Total money made by the racetrack. Okay, so 34, let's say they decrease the price by 34. Now, 20 more are going to come race, so that would now go from up to 400. Okay, so would they make more money by doing that? Going cheaper, but getting more money. So you take 34 times 400, that's going to be 13,600. So yeah, they do go up. Okay, if they go down to 33, then this is going to go up by another 20 more people come. So 333 times 420, going to be 13,860. Okay, 32 goes up, so 440, and it went up, but that went up by 300. That went up by 260. So we can tell already it's not going up by a constant amount. Okay, so 32 times 440, that's going to be $14,080. Okay, so it went up again. It went up by 220 that time. So 31 times 460. 14,260, because that goes up to 460. Okay, and then times 480. 14,400, still going up. 260, it's going up by kind of slowing down, going up by 140 that time. Times 20 more racers, that'd be 500. So 14,500 went up by 100 there. So if you kind of notice, you're going up, but it's going up by a lesser amount every time. Okay, and then times 520. 28 times 520, that's going to give you 14,560. Went up by $60 that time. Okay, $27, you'd get 540 people. So as you can see, got that, so 14,580. So man, it went up, but only by $20 that time. And then times 560. 26 times 560. 14,000. Okay, now it's back down. 14,560. So let's see if that's coincidental or if it's just going to keep going down. So 25 times 580. That's going to be 14,500. Okay, no, that went down again by 60, and which makes sense because, look, if I keep decreasing the price, eventually I'd just be giving away the races for free, which would mean I would not be raising any money. So yeah, I went up for a while, but there came a max point right there. So this wasn't really a line. What this was, it's called a parabola, okay? If you have me, we went over that at the end of last year. Now it says, what's the difference between the values generated in the second column for each table? Okay, well, the first table, they go up by a constant rate, and that's why that's represented with a line. And the second one, what they do is, it's called parabolic, okay, meaning it goes up, hits a peak, and then it goes back down. Can't write here. Well, why do the values generated in the second column behave the way they do? Again, because if price decreases too much, you are not charging enough. And again, it says if you had to graph these tables, what would they look like? Well, that'd be a line, and this would be a parabola. Okay, and that's what we're going to get into in this next standard is parabolas. Okay, now there's something I want you to take a look at here. It says y equals x to the second plus 6x minus 7. Now, you know this is going to be, okay, so let me generate this. So I'm going to plug in 0, 1, and 2 in that equation for x. So x to the second, so I'm going to go 0 to the second plus 6, and then 0, and then minus 7. So that gives me negative 7. Okay, now let's plug 1 in, so parentheses 1 to the second power plus 6 parentheses 1 minus 7. Okay, it's 0. Now let's plug 2 in. So parentheses 2 to the second power plus 6 parentheses 2 minus 7. That gave me 9. Okay, now let's check this one out. Let's plug 0 in. So 0 plus 7. And then, by the way, you could probably do this one mentally. I mean, it's going to be 7 times negative 1. Okay? Because that's going to be negative 7. Okay, now let's plug 1 in, so let's put in 1 plus 7. 1 minus 1, I think that's going to be 0 because you'd have 8 times 0. Yeah. Okay, and then 2 plus 7, and then 2 minus 1. So that's going to be 9 times 1 is 9. Okay, now let's do the last one. X plus 3, and now all that's to the power of 2 minus 16. Okay, so I'm going to plug in 0 plus 3 to the second power minus 16. Gives me negative 7 again. And guess when I plug in 1, good chance I'm going to get 0. We'll see. Okay, 1 plus 3 second power minus 16. Again, 1 plus 3 is 4. 4 to the second power is 16, and minus 16. Oh, 0. Now let's plug 2 in. So 2 plus 3 second power minus 16. Is that going to be 9? Well, yeah. I got 5 to the second, which is 25. Minus 16 is 9. What do you notice happens? Compare your tables. The same. But the equations don't look the same. Why do you suppose this would be? That's because they are in different, same equation. They're really all the same equation. That's why you got all the same answers, the same ordered pairings. But it's just different forms. Okay, now here's what I want you to write. This right here is in standard form. And by the way, you know these are parabolas, okay, because of the second power, x to the second power. Anytime the highest power is a second power, it's going to be a parabola. Now, you don't see a second power, but you see it is because you're taking x times x. X times x is x to the second power, okay? And then here, that's x to the second power 2. So they're the same equation, just in different forms. That's standard form parabola. Now we went over standard form on the assessment. You're like, well, that doesn't look anything like standard form. Yeah, but that was a line. These are not parabolas. So that's standard form. This is what's called factored form, because you have two factors. X plus 1 is a factor, x minus 1, x plus 7 is a factor, x minus 1. And that is called vertex form. Those are the three names: standard, factored, and vertex. Okay, now, generate tables for the following equations. Use 3 through negative 3. So if I take 3 times negative 3 is negative 9, plus 1 is negative 8. 3 times negative 2 is negative 6, plus 1 is negative 5. And then you're going to get negative 2, and then 1. You notice how it's changing by 3 every time. Okay, and again, now let's plug in negative 3 into that equation. So 5, and then negative 3 to the second, plus 1. It's 46. 5, and then negative 2 to the second, plus 1. This is pretty easy to do mentally. Negative 2 to the second is 4. 4 times 5 is 20, plus 1 is 21. Okay, let's plug in negative 1, 5, and then negative 1 to the second, plus 1 is 6. If I plug in 0, you're going to get 1. Okay, now let's plug 1 in. 6. Okay, now what it's going to do, it's going to go back up. If you plug 2 in, you're going to get 21 and then 46. Okay, so what's the difference in regards to the change in y values between the tables? Okay, again, this goes in a line and this goes down, but then it comes back up. Now the reason the difference occurs is because this has a second power. That's what causes it not to be a line. That's what causes it to behave that way. Okay, and then don't forget, just forget the next thing. Okay, now let's finally get to the assignment now that I've kind of bloviated through that. And you're graphing equations. Now, first out, this will not be a line. Anytime the x variable is to the second power, it's going to be a parabola. If we have a positive leading coefficient, which we do, the 2, it's going to look like that. And then I need to know what form the parabola is in, and it's, if there's no parentheses, it's in standard form, okay? So what I do is I make a table, but I got to pick the right numbers for x. You can't just pick anything you want. You got to find the sweet spot right here, the middle, and then I can pick 2 side points. Now, you're like, well, how would I do that? Just guess and check where the low point is? Well, that's one way, but there's a much quicker way. It's a formula, a short formula, not the song, okay? That's different. The song is when I'm finding the 2 answers for x. That's not what I'm doing. I'm trying to graph a path, okay? What I do is I take that number in front of x squared, that's the a coefficient. The number in front of the x is the b coefficient, in this instance negative 8. Now that's a c, but I'm not going to use c. The formula to find the middle point for your x is known as the opposite of b divided by 2 times a, 2a. So the opposite of the b is 8. Okay, don't put x with it. It's just 8 to be positive 8. Divided by, and then what I need to do with my a coefficient 2 is I'm always going to times that by 2. I'm always going to double it. Well, 2 times 2 is 4. Now I take 8 divided by 4, I get 2. Okay, so the middle's 2, and now what I do, that's the vertex, that's what that's called. I go one higher and one lower, and then I'm just going to plug it into my calculator. So I'm going to plug 2 in for the x's. So 2, 3 to the second, because it's 2x to the second, minus 8 times 3, plus 3. And you can use, please excuse my dear Aunt Sally if you don't have a great calculator. That's negative 3. Then 2, and then 2 to the second, minus 8, and then 2, and then plus 3, gives me negative 5. Now I plug the 2 in. So 2 and then 2 to the second minus 8, and then 2 in for x again, plus 3, negative 5. And wait a second, I did something wrong there. Why did I put another 2 in? That's stupid. 3, 2, 1. Okay. 2 parentheses 1 to the, gosh, struggling here, having a hard time. Minus 8, and then 1, and then plus 3. Okay, so negative 3. So these two should end up the same. If that's the vertex, then these ought to be the same. It's symmetrical. So 3, negative 3. 2, negative 5. And you're like, why are we even doing this? What's the point? Well, eventually, all it is to show you why x to the second powers act the way they do. Really the only point. And you're like, oh, I don't like graphing, and I don't either. I've said that. Okay, so there we go. But this really isn't that hard. Okay, here's the second power. Okay, so that tells me it's a parabola. The leading coefficient's 1. It's positive 1. So again, it's going to behave like that. And again, if there aren't any parentheses, it is in standard form. Okay, standard form parabola. It's not the same as a standard form line. Okay, so the way to graph a parabola is to find the sweet spot in the middle, and of course with standard, the way to do that is have an A coefficient and a B coefficient, and we're going to use the short formula opposite of B divided by the product of 2 times A. So the opposite of B is positive 5, and then I take my A, the A coefficient 1, I times that by 2. So that's 2. 5 divided by 2 is 2.5. Now there are a couple of different ways you can go about this. You can go 3 and then 2, or you can just go one higher and one lower. Either way, you're going to get a good parabola, guaranteed it. Okay, so 1, and then we're going to go 3.5 to the second minus 5, and then 3.5 plus 4, negative 1.25. It's kind of odd. Okay, 1 and then 2.5 to the second minus 5, and then 2.5, and then plus 4 gives you negative 2.25. And I'm hoping that ends up the same as that. Okay, I'll know I did this right if those end up the same. Okay, you will. Or sorry, if this is 3.5, that's got to be 1.5. Man, I'm struggling. 1 and then 1.5 to the second minus 5, and then 1.5, and then plus 4. Okay, so we got it. We got negative 1.25. You could also go 2 higher than this and 2 lower than this, as long as you're kind of symmetrical. So 3.5, that's 3.5, and then negative 1.25 is just between the 1 and the 2. 2.5, and then down 1, 2, and then part way. 1.5, and then down 1, and right there. Okay, so that is my parabola. This is my vertex. So that's standard form, opposite of B over 2A. Okay, I'm going to go on this and I'm going to write standard. Know that if I have standard form, that means there are no parentheses. The way to get the middle point is opposite of B divided by the product of 2 and A. And then I go one higher, one lower, and then voila. Now the next problem, y equals x minus 3, 5 times x minus 3 times x minus 5. Now you do have x times x, so that's x to the second. I'm not going to multiply it out. Okay, we're not going to do that. We don't want to do that. We want to keep it like it is. But it is still a parabola. The lead coefficient 5 is positive, so it goes like this. So again, that's the sweet spot. But this isn't in standard form. When I have 2 parentheses like that, it's in factored form. With factored form, you got to use a different technique. Here's a technique to use. You take the 2 factors of your parentheses, x minus 3 and x plus 5. And what you're going to do is set those both equal to 0, okay? Just like that. So we plus 3 and plus 3, and I get 3. I subtract 5, and I get negative 5. Now those two are my outside points, so 3, negative 5. Okay, that's going to be these points. Now I got to get the middle. What I do to find the middle is find the average of these two values. Okay, I add 3 and negative 5. That's negative 2. And then I divide that by 2, because that's how we always find the average of two numbers. Divide them by 2, and that's negative 1. Okay. Now, funny thing with factored form, that should be 0 and that should be 0. Okay. That's what factored form does. It actually finds your x-intercepts for you. So 3 minus 3, 3 plus 5. Okay, I end up getting 0, just like I hoped. Now plug in negative 1. 5, negative 1 minus 3, negative 1 plus 5. Okay, negative 80. And you're going to find that a lot, that the vertex is going to be really far away from these. You're going to get some extreme values for your vertex. Okay, and then 5, and then negative 5 minus 3, and negative 5 plus 5. You can tell you're going to get 0 because that last factor, negative 5 plus 5, is 0, and the 0 product property means you get 0. Okay, so 3, 0, I go 1, 2, 3. Then I go left 1. I'm going to go by tens. 10, 20, 30, 40, 50, 60, 70, 80. And then negative 5, 0, 1, 2, 3, 4, 5. Okay, and it's a parabola. The factored form parabolas are pretty wide, okay, unlike the standard parabolas that are kind of narrow. Okay, again, we got x times x. I'm just going to put that there so I know that that's x squared. It's another parabola. Okay, so the lead coefficient this time is negative, so it's going to go like that. Okay, it's still the middle and the sides. Okay, and again, 2 parentheses means it's in factored form. Okay, so with factored form, we take each parenthesis factor and just set it equal to 0, because that's going to find our x-intercepts for us. So plus 3, I get 3. Minus 4, I get negative 4. Now, those aren't your vertex. Those are actually your side points. So 3, negative 4. Now what I do is I find the average. I add 3 and negative 4, it's negative 1, and then I divide that by 2, and that's negative 0.5. It's like finding the average of the two numbers. Okay. Now again, with factored form, those two outside points should give you 0, which makes sense. 3 minus 3 is 0. You can put in 3 plus 4, but it's still going to be 0. Okay. And then negative 2, and then negative 0.5 minus 3, and then negative 0.5, whoops, plus 4. Okay, so that gives me 24.5. We'll go by 5s to hit that. And if I put in negative 4, you already know that's going to be 0, because if you put in negative 4 plus 4 is 0. I mean, even who cares what that factor is or what that factor is? If one of the factors is 0, it's all 0. So 1, 2, 3. I go left half, that's just between the 0 and the 1, then 5, up, 5, 10, 15, 20, and then 24 is 0.5 somewhere in here. So 1, 2, 3, 4, okay, and there we go. Okay, now the last two graphs, we're not going to go over all the graphs here. Okay, there's some that are completely useless. Oop, I skipped a page. Okay. Whoa. Okay, y equals 4, and then x plus 2 to the second minus 3. Okay, so x second means we have a parabola. The 4 in front's positive, so it's going to be like that. Look like a U shape. But this now, when I just have one parentheses and that entire is to the second power, then it is in vertex form. Okay? Here's why it's in vertex form. Because the vertex, you just take that parentheses, set it equal to 0, solve it, and negative 2 is your x vertex, because a vertex is easy to find. So it's going to be the opposite of that. So higher and lower. So I plug them in. So I've got 4 and then negative 1 plus 2 to the second power minus 3 gives me 1. 4 and then negative 2 plus 2 to the second minus 3 is negative 3. And by the way, and if it's in vertex form, your vertex is the opposite of that, and then the y value always ends up with that, okay? Because a vertex, I know what the vertex is when I look at it. That's why it's called vertex form. So 4 and then negative 3 plus 2, second power of that, minus 3, 1, okay? So I go left 1, up 1, left 2, down 1, 2, 3, left 3, up 1, and these again are narrower. Okay. Next one, we got x second. That's a parabola. The lead coefficient's negative, so it's going to look like that. And again, one parentheses is vertex form. Okay. Okay, so x minus 5, I just set that equal to 0. It's going to be positive 5, and that's your x at the vertex. I'm guessing the y that goes with it is the 6, but we'll find out here momentarily if that's the case. So negative 3 and then 4 minus 5 to the second plus 6 gives me 3. Let's see if that's 6, just like I predicted. 5 minus 5 to the second power plus 6 is 6, just like I said. And if I plug the 6 in, that's going to be 3 as well. So 4, 3, 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 5, 6. 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then 6, 3. Okay, and it's upside down just like we predicted. Okay, cross out this absolute value graph idiocy. Okay. The other thing I want to go over is simply the FOIL method. We got 7x plus 3 times 2x minus 5, and that's a negative 5. So what I do, since I can't add those or add those, I go first 7x times 2x. Then back 7x times negative 5. 7x is done. I've distributed that. 3 times 2x and 3 times negative 5. So that's going to be 14x to the second power, because they both factors have just x. It's going to be negative 35x, 6x, and negative 15. And these two are like terms, because they both have regular x. So I got 14x to the second. Negative 35 plus 6 is negative 29x. And then the negative 15. And you can just put minuses if they're negative 2. Okay, another FOIL one, that's a coefficient of 1. So negative 8x, negative 3, 1x, and 2. So I've got 8x times 1x, 8x times 2, negative 3 times 1x, and negative 3 times 2. So that's going to be 8x to the second, 16x, negative 3x, and negative 6. Those are like terms. 16 plus negative 3 is 13x, and then negative 6. Okay, now your assignment, you need to do that. That's a parabola in standard form. You're going to need the opposite of b over 2a. That's in vertex form. There's my 4 and 3 is a vertex. That's in factor form. We set those equal to 0. Those are your outer, and you need to find the average. Get rid of this absolute value idiocy. And then you need to find the product of those expressions. Okay, so 5 problems. They don't take long. I was pretty windy today, so